So today we are here for the master thesis defense of João Francisco Lino Daniel. The title of the thesis is Automatic Detection of Patterns in Microservice-Based Architectures. The committee is formed by me, Professor Nabor das Chagas Mendonça, and Professor Rami Basson. How was my... okay. Okay, so I'm not sure. João, Nabor, how much time usually you have for presentation?
It depends, but with the PhD, we like downgrade the defense for master students. So usually like half an hour.
Okay.
30 minutes, 30, no more than that.
Okay, so João, you have half an hour for presentation. Welcome. I want to thank Professor Nabor and Professor Rami for being part of this examining committee. And João, please, you can start.
Thanks, everyone. Thanks for your presence and guidance. Without further ado, let's begin. So, how much do we know about microservices patterns? And if it's not that much, how can we improve it? My name is João Francisco. I'm a master student. I'm presenting my work here called Automatic Detections of Patterns in Microservices-Based Architecture. And I'm co-advised by Professor Alfredo Goldman and Professor Eduardo Guerra. So this is the agenda for for my presentation here. We have 5 main sections according to this listing. I'll try to be very brief in the 2 or 3 firsts. We are going to be focusing on the contributions achieved since the qualification, mostly this 4th section here. So let's dive into the introduction. In this section, I will present an overview of the entire project during the master. So the context we are talking about is, okay, microservices is a very popular architecture choice nowadays. We have many large corporations that adopt it, and it is and we also have a comprehensive set of patterns for microservice architecture. We have several different solutions for several different problems in different contexts. But we have a few studies on how professionals use these microservices patterns. And we also have limitations on the tools focused on microservices and more specifically on microservices patterns. What are the objectives in this project? We currently have 2. First one is the assessment of the knowledge and usage of microservices patterns, guided by these 4 pillars here: the knowledge, the usage, the unaware usage, and how the professionals implement the patterns in their architecture. We also have a second area that is automatic detection of microservices patterns. And this is the 2 main guidelines we focus on these second objectives. How to represent microservices-based applications by its metrics, and how to provide a technologic agnostic approach for detection of microservices patterns. And the outcomes we achieved with this project were also divided in the same 2 areas. We discovered that the community, the professionals, have a more theoretical knowledge about microservices patterns. But in terms of adoption of the patterns, we have a lower degree of adoption and a lower awareness of the adoption. And we have a considerable unawareness degree of the microservices patterns. Regarding the automatic detection, in this project, we came up with Microservices Vision, a detection tool. It is technology agnostic by being metric-based. We have a supported accuracy degree, supported by the data of the experiments that we conducted. and it came up to be useful for highlighting architectural decisions and guidelines besides the patterns itself. And this is an overview of the entire methodology adopted in this work. Don't worry about many of the details. I just want to highlight that we have two works. The first one is reddish here on top. The second one is these two steps in blue, but I will approach them in a more deep way in future slides. So this was an overview of the project. We have now a brief talk about the background, the theoretical background we have here. So what are patterns and what are pattern languages? Why are they important? So a pattern in the context of our work here in software architecture is a recurrent solution for a problem that happens in a given context. So it's not something that someone invents, someone creates. It's something that we discover, something we simply document by being a recurrent solution for a problem. And a pattern language is the set of patterns, because the patterns are not isolated. They work together, they are connected, they can improve each other's solution. So we call this set of patterns as a pattern language. And these two knowledges, these two concepts work together in the sense that patterns drive the implementation according to the guidelines and the desirable quality attributes of a given type of architecture. And what is microservices, the main architecture we are talking about today? So we are used to thinking about scalability in our software systems. And we know the vertical scalability is when we provide a stronger hardware, a more powerful hardware. And we have also horizontal scalability when we create different replicas, different copies of the same program to deal with the load of the system. But microservices goes in a third dimension. It's something like a logical scalability, where you divide your application into smaller parts, and each part has its own responsibility, and they all cooperate to achieve greater demands of the users. So this is what we understand by microservices in a very in a nutshell. So I mentioned that we have many different microservices patterns, and this is just an excerpt of the pattern language that we have. These are some of the patterns that we worked in this master's project, just to represent how comprehensive this pattern language can be. This is just less than a half of the patterns that we currently have documented nowadays. So now about a little bit about detection in software architecture. So more specifically in microservices architecture, the literature has many different works of detection and automation in software architecture for microservices. We have many different works that recovers the plain architecture, which means they detect which are the microservices that are running in a currently system. We also detect, we also have works that detect bad smells, and all these works rely both on static and dynamic analysis, which means they either read the source code or configuration files, or they can analyze traces and logs during runtime. But mostly, usually these works are technology dependent, such as they rely on the JVM or standards like Java EE. There's a very interesting work by Lanza and Marinescu in the scope of object-oriented programming, and they propose a technique to assess the software architecture with metrics. And among this work, they present the technique called detection strategy that combines metrics in such a way that can characterize the presence of a given structure or a given pattern or a given anti-pattern. In this representation, we can see the God class definition based on metrics. So we have 3 sets of metrics here that can be combined to detect a God class. And this work inspired our work here for detecting microservices patterns. So a little bit about knowledge and usage of microservices patterns. This is the first work of this project. And what were the goals and drivers? I'll be very brief in this discussion because I want to focus on the tool. But we conducted an exploratory data analysis during this master's. And it was driven by these 4 research questions. First, how much are the investigated patterns known by the professionals? How often do professionals implement each investigated microservice pattern? 3, are the investigated patterns solutions applied without the professional's previous knowledge of the pattern? And 4th, how the investigated patterns are introduced in the systems that implement them. So these 4 questions drove this exploratory data analysis, and I'll present the key takeaways of this work. First, we found evidence that supports that the community, the professionals, have a high level of knowledge. And the main learning source for the professionals are learning from examples. This seems to be a very promising way to learn about microservices patterns. About the second question, we see a lower degree of adoption of the microservices patterns, even with core patterns such as API gateway and database per service, for example. But when the patterns are indeed used, they often are combined with other patterns. We saw that they are usually implemented in pairs or in trios or something like this. The third question, we found that 1 participant out of 3 discovered while answering our questionnaire that they had implemented patterns. They didn't know prior to the questionnaire they had already implemented their solutions, but during the response of our questionnaire, they discovered that the solution that they had, it was actually a pattern. So this kind of raised a flag for us that there is a considerable amount of unawareness amongst the microservices patterns. And the 4th takeaway is that the microservices patterns are often adopted since the design, since the inception of the architecture. Although refactoring is still relevant, it is usually the refactoring from a monolith to a microservice architecture. So based on these feedbacks, we move and we go to the 4th and main section here for today, that is automatic detection of microservices patterns. So what are our goals based on what we learned on the first work? We want to represent microservices-based applications according to its metrics. We also want to craft arguably accurate technology agnostic strategies for the detection of microservices patterns. These 2 goals are based on the experience that we acquired during the exploration of the literature and this first data analysis that we conducted. So what is the methodology that we adopted in this part of the work? So this work was basically divided into 2 main blocks, into 2 main stages. The first one I called an exploration stage. It was a very narrow scope for our study. We were basically trying to gain the first grasps on the concept, on our practice, on our approach to detection. So we created basically a toy example for a study case, and we implemented a first prototype of our tool with a single database per service detection. And based on this exploration stage, we had some feedback, internal feedback, and it encouraged us to move along to a consolidation stage, this second block, where we basically expanded the scope of the number of the patterns that we were working, the number of metrics we were collecting, and we applied two case studies with real-world applications. So we had to collect the data and analyze and model it according to our tool. And finally, we reached the final assessment with the developers of these two real-world applications with the outcomes of our tool. So this is an overview of the methodology. What patterns did we include into our study? We included a database per service that will be represented by these initials DBPS. We included single service per host. The initials are SSPH. We included asynchronous message, AMSG. And there are two more patterns, the Common Query Responsibility Segregation, CQRS, and finally, API composition, that is APIC. Okay, so just to give you a glance of what the metrics were used in this part of the work, we use metrics such as the number of microservices clients that a given database has, or how many microservices compose a given deployment module, or also Boolean metrics such as does a microservice M access the database D? And these were some examples of the metrics. This listing is actually complete. This is the entire list of metrics that we used, but I just presented 3 of them. And here are some visual representations of the detection strategies that we crafted during this work to represent the microservices patterns. So, for example, in the database per service here below, we can see that we try to analyze a database with an exclusive access. So it only has one microservices client, a microservice with a cohesive set of operations. So the number of operations in a given microservice is fewer than too many, and this is a statistic threshold. We try to avoid the perils of dealing with this statistic threshold. And also the third one, the microservices M accesses the database in the given database. So the combination of these 3 factors based on metrics, we characterize the database per service pattern. And here we can see the same idea behind the asynchronous message or single service per host. And here we can see the combination of metrics for the API composition or for the CQRS detection strategy. So let's continue. So so far we were talking about a theoretical, a conceptual approach with metrics. We had no implementation so far, but now I will begin to talk about the automation, the tool that we implemented for this detection, for this master's project. So here I present the requirements for this automation. I present the functional requirements. We had to read an application represented according to a given model, a fixed model. We had to extract the metrics from the data. We had to automate the detection strategies, this one that I just presented the illustrations. And fourth, we need to provide a reading access to the results, so we could see which patterns were detected and which were the instance of each pattern. And the non-functional requirements, we also had 3 ones. The number one, we needed to have utility during the entire application lifecycle. So this is something that drove us to follow this technology agnostic, because we wanted to provide a tool that could be useful even prior to the implementation, just by a conceptual modeling of the architecture. these two could be useful already. The second non-functional requirement would be to be available for the community to contribute, because we know that we can only do so much when working alone, and we want to bring the community together to increase the awareness of our knowledge on microservices patterns. So it was important for us to be available for the community to contribute. So we created an open source project. And the third, it's kind of a derivation of the second. We needed the tool to be designed in an architecture that could be easily extensible, in a way to facilitate new metrics to be collected and new patterns to be detected. So we tried to create this tool not only to detect the patterns, but to work as a platform for future implementations to be easy to extend. And here, this is the, now I will present a little bit about this architecture, how we implemented this tool. This is the model that I previously mentioned. This is how we model, represent microservice system architecture in our tool, in microservices-vision. We can see, for example, that a service can publish a message to a message channel, or it can consume operation for another service, for example. This is the architecture that we define for the collection and the detection, the collection of metrics and the detection of microservices patterns. So these core abstractions basically represent every single one of these abstractions here, and they all implement an interface called visitable. And we adopted the design pattern called visitor to provide an easy way to traverse this complex graph, this complex network of abstractions, to be able to measure and collect the metrics initially, and then detect the patterns based on these metrics collected, so we could finally detect and represent the patterns by this interface called pattern. So this is the behavior that we follow in the tool. Initially, the client dispatch a metric collection, the metric collector, which will then visit the core abstractions and traverse this graph, collecting the metrics and storing them for future use. And then for each pattern detector, the client will dispatch the concrete pattern detector, that each one will visit the core abstractions, now with the records of the metrics that were already collected. And finally, for each instance that that detector find of a pattern, it returns a set of the instance that it found for the client. So this is the basic behavior, the workflow. First, the dispatching of the metric collector, then we dispatch each one of the metric, the pattern detector, that will basically all traverse the graph, trying to read the metrics. So I said in the first block of the methodology, we had a narrow scope study, and it was the first assessment we conducted with a toy example, a system that we created inspired on Twitter, we called Pinger. And we can see that there are some microservices here, their database usage here in yellow, and each of these blue boxes are one operation. So we first implemented a prototype, and we ran against this system, and we could see that the tool found 3 instances of the database per service pattern, and it was according to what we expected, because there's only 3 instances of the pattern here in this system. And so we moved to a second stage of our implementation to expand the tool, the number of metrics and the number of patterns detected. We collected the data for 2 real-world applications, and then we conducted 2 case studies with this applications. So what were the goals of our case studies? First, we wanted to extract and analyze metrics from real-world microservice-based applications. The second one was to detect microservices patterns based on those metrics. And the third was to validate with the developers of the application the metric-based approach regarding its accuracy and the scenarios of use of its relevancy, its utility. So we conducted semi-structured interviews, and this is an overview of the script without many details, just to give the big picture. We initially presented our goals, the tool, its approach, its metric-based approach, how could we represent each of the patterns. Then we presented the architecture of reference for that, for the system itself, because the collection of the data was done manually, so it was more than likely we would have differences between the data that we collected and the current implementation of those systems, because those systems are alive and always in change. So we began by presenting what were our view on their architecture, on their data, because it was kind of something like with a timestamp, something like that. Then we began discussing, for each pattern, we were evaluating the detections of our tool. So we basically addressed two main issues. First, we tried to do the agreement with a positive case. We presented all the positive cases of our tool, and we tried to see if they were true positives according to the developers of those applications. Then we asked if the developer was missing any detection instance. So if our tool presented some negative results that were actually false negatives that should have been positives. This happened for each pattern, and by the end we finished by addressing something directly on the tool, how the tool works, how the approach is relevant or not, where are the limitations of the approach, and how is the tool useful during the life cycle of creating, incepting, and maintaining microservice-based application. And here are the results summarized into a table. First, I want to present the structure of the table, then we move into the data itself. We can see in each row of this table, we have the 5 microservices patterns that we studied. In this first block on the left, we can see the positives and the negatives detections of the tool for the first system that is called Intercity. So we can see the 3 interviews, interview 1, 2, and 3. And on the right side, we can see the handicraft marketplace. That was the second one. So we can see that we only have 2 interviewed people for this system. And in the table, I will point some cells are AG that represents agreement, or in some cells are PT that represents partially agree. So for the first system, we can see that in the cases that the patterns were actually detected, the majority of the interviews and in the majority of the patterns, there was agreement according to the detections. So they mostly, the participants mostly agreed with the detections. And in the negative case, they had some regards, some considerations about the lack of detection, but they mostly agreed. They also mostly agreed with the outcomes of the tool. In the second system, things were a little different. Oops, sorry. In the second system, things were a little different. In the positive case, we can see that it's more like 50-50 between fully agreement and partially agreement about the positive cases. But we had a consensus about the cases where the patterns had not been detected by the tool. Sorry. So what are the discussions of this work? What came up to our work? we identified that microservices vision is indeed a technological agnostic due to its metric-based approach. So following a metric-based approach can indeed provide this tool that does not depend on the technology, on the stack of our platforms and programming languages. And it's arguably accurate for the patterns that we consider. The arguably accurate is because we support this with the interviews with the professionals. So according to the professionals, we have arguably accurate pattern detector. And this accuracy statement is more reliable for the patterns with more detection instances. So I'll go back one slide just for 1 minute. We can see that patterns such as database per service or single service per host, we were dealing with many different instances. One system we had 4 and 3, or the other system we have 11 instances and 7 instances of those patterns. But for example, API composition, we had no instance whatsoever in any one of the systems. So we can only rely on this accuracy statement for the patterns that are more frequently detected. But in general, the tool has some considerable accuracy. We also saw that this tool, proposing this tool and making this tool available, is useful for reasoning about the architecture. And this is something that came up during the interviews, something that the participants mentioned, and I will present some quotes of them. One said, "I agree with all the detections, and I think there should be more occurrences. This is something we need to implement yet." And this person was talking about all the detections that were, all the instances of a given pattern that were detected by the tool. He actually agreed with them, and he thought that there should be more implementations of these patterns, because where the tool did not detect, it actually wasn't present indeed, and he thought it should be. So just by having this feedback of the tool was something that could provide some insights for improving the architecture. We also had the original goal of one microservice was to act as the composer element of this pattern. We are talking about CQRS. But from what I'm seeing here, there might have been an architectural drift during the implementation. So this person was agreeing with the lack of detection, that there wasn't no instance of CQRS in this case. But this brought evidence for this person to assume that there might be a drift. So it's an area of the architecture that should have more attention in the future. And finally, there were some considerations regarding the approach, the limitations of the metric-based approach of the tool. So one person asked, how can microservices vision be sure that one microservice is actually performing the join internally, also related to CQRS? And we said that unfortunately the tool could not do that. There was no possibility for the tool to actually be sure that the join was being performed there. But this was because of the metric-based approach. We can only focus on the structure of the microservices and how they interact, but we weren't analyzing anything internally of the implementation of each microservice. And this was something that the person was concerning about the metric-based approach. So, and this is just an example of the concerns about the metrics, how they were limited to consider the semantics of the microservice of the implementations. So the metric base is more structural than semantic, is more syntactic analysis than a semantic analysis. And this is a limitation. Of course, we miss some aspects when we cut off the semantics of the analysis. And to wrap up this presentation, to present all the contributions and the conclusions of this master project, first, we addressed the lack of studies on how professionals know and use microservices patterns in the industry. We found a high degree of knowledge in theory, but we also found evidence that in practice there is room for improvement. And finally, there is an intermediate level of awareness in microservices patterns that we also can improve as a software development community. We also proposed an approach to increase such awareness about microservices patterns with microservices-vision, a tool that automates the metric-based detection of those patterns. And this tool additionally is useful to support the decision-making on top of a microservices architecture of a given service. So with that, I wrap my presentation. Thanks for your attention, and now I open for your considerations and comments.
Thanks a lot, João, for your presentation. As a tradition, we always start with the person that is more far away from, let's say, from the student. So I would like to invite Professor Rami to start the argument.
Okay, first of all, João, I have to thank you for the excellent presentation and very informative, in fact, and you've been able to cover the entire study that you've conducted in a systematic manner, and you've communicated the good and the bad things about your approach. So one general question which I have for you is mainly, what are the criteria that you've taken to distinguish between service and microservices? Because, practitioners, they could be implementing services and, just to be on the fashion or to follow the fashion, they will claim that this is a microservice. So I'm not sure what sort of criteria you've used to distinguish that this is a service and this is a microservice.
It's a very important issue, this one. I have, let me go back in the slides just for a moment. I have one case that we can address this. You're still seeing my presentation, right?
Yes.
Okay. So in the case of the database per service, one of the criteria to detect this pattern is to consider that a microservice has a cohesive set of operations. We understand that a microservice is a unit of deployment, and a service is a logic unit of runtime, of execution. So a microservice might have one or more services within implemented. And we only consider a microservice when it only has only one service internally. So in other words, a microservice is a service with a single responsibility. And we try to address this with the metric that I presented here. There is microservices having a cohesive set of operations. And in terms of metrics, we said, okay, the number of operations of a given microservice cannot be larger than a given threshold. Initially, we defined this threshold statically in a configuration file. So we defined this as 8 operations is the top limit for the number of operations. But this is one point that we should explore more. There is the need of more exploration to understand where this threshold would fall to be more reliable.
Okay, I think that's very interesting. Starting point. Have you thought about linking the standalone, for example, service that you are telling that a microservice should have one standalone service or should be focused on one particular functionality? And as part of your presentation, you've mentioned something very interesting, that the automated detection and your method can help architects to rethink whether they are compliant with some patterns or whether they can further refine or elaborate their design to look like some patterns which are, widely acceptable. So suppose, for example, I'm implementing a microservice and I've ended, bundling two functionalities together. But I thought that this could be efficient. Then I've used your approach, and your approach could invite refactoring in order to be compliant with some of the patterns that you've already, investigated, or you've already mentioned that they could be good for you to use. Do you think there's room here for further work in the future, for sure, not as part of your MSc, to rethink the scope of microservices based on the automated approach that you've taken? So, for example, I could still apply your approach to services, and then I could detect the services which could be candidate for getting into microservices and being compliant to patterns. So I'm not sure whether you have any intake on what I'm proposing here.
Yes, this is something that is, I think it's a possible point of extension of this work. It would be very interesting. And about something you mentioned of the outcomes of the tool, kind of suggesting a refactoring. We try to follow an approach on the assessment with the feedback of the real developers, so we could actually have some insights on how much this hint or this suggestion to refactor will be present. And because we understand that the rule of a pattern is only present if the developers think so. It's not something I can. The tool could not say it is present or it is not present. It's like something like a hotspot. There a high probability of this pattern being present, and so this is something we need to take into consideration when analyzing the outcomes. But going back to the original question about these extensions, I think it's possible, it's useful for sure, and I don't think it will be that much of a trouble to implement it, because it would only require a slightly small change to the model to represent a microservice and a service in a different fashion. We only represented it as a single abstraction. But for sure, it would be an improvement for the tool if we implemented this separation of concerns.
Okay, perfect. So you've mentioned that you've used several metrics, which I think it's as well an excellent starting point. So what about the completeness of these metrics? Do you think there are rooms for extending, adding more metrics, or what you've provided, they are core and they should be sufficient? Or I could continue to apply with higher, yeah.
No, it's an excellent question, because the metrics that we adopted in these detections, I listed them here in these 2 slides, and they are definitely not complete for all the patterns. These are just I try to follow a kind of an agile approach to this. I went on adding new metrics according to what I was needing. So I came up with a pattern that I could detect with metrics. So, for example, I had database per service, and I saw, okay, from detecting database per service to detecting single service per host, there's just a small step of changes between one to another. So what are the new metrics that I could investigate or collect to support the detection of a single service per host? Okay, these are the ones. So I just added the necessary for the detections that I conducted in this study. But for sure, there are many others. Actually, this work is inspired in other works that analyze and collect which are the relevant metrics and which are other works who actually address this issue of coming up with a complete set of metrics for microservices. This was definitely not something we were worrying about in this masters.
Okay, that's perfect. So the reason why I've asked this question, because you've used a set of metrics, and suppose, for example, I will be adding additional metric. Do I still get the patterns, or do I think, for example, I might be getting completely different interpretation of how these cases, they tend to comply to specific metric, to specific patterns of interest?
Yes, there might be, with new metrics, there might be new interactions about the thresholds and how we characterize a given microservice. And there could be the case when you had a perfectly working detection, and just by adding a couple of more metrics, simply that detection doesn't make any sense anymore. So this is something to be concerned in this expansion of the metric set, for sure.
Okay, perfect. I have one question, but I'm aware that this question is complex, and perhaps it could take you toward the PhD in that area. So in case, for example, I need to think about the quality aspects, quality attributes, because at the end, you implement an architecture and you are interested in meeting some quality attributes of interest. And you've mentioned the reason why we use microservices is mainly for scalability reasons, right? So in case, for example, I need to extend your approach to see whether the patterns which I'm using, for example, they are fit for purpose in meeting some quality attributes of interest, or maybe they are good in balancing some trade-offs of interest. Okay, like I'm interested in scalability, but at the same time, I'm interested in decentralization, security, and maybe reliability for the entire application. So I'm not sure, how this work. I know that this is beyond the scope of your work, but how this work could be extended, or how you could think about maybe introducing the quality attribute aspects, trade-offs, and maybe suggestion for refinement or elaboration, or maybe switching to alternative patterns that are best fit for these qualities.
Mm-hmm. Yes, I think we never mentioned that, but the effort of my masters is contextualized within a larger project. Eduardo Guerra has another student, a PhD student actually, who is Tatiani. She's conducting a research to provide characterization model for microservice, and this is very closely related to the quality attributes of actually the quality attributes is the linking point between her work and my work. We could bring these two together. In a subsequent effort, there is a undergrad student here at University of São Paulo, advised by Professor Alfredo, who is implementing a platform, a visual tool, website for navigating and exploring the metrics of Tatiani's model in a visual fashion. And this student, Eric, also implemented something that you could see the dimensions of the model that we could kind of put a focus or highlight, kind of put the glasses of the synchronous coupling or asynchronous coupling and so on. In a very recent meeting that I had with Eric, we were discussing how to integrate our tools, how my tool could enrich his visualization, and the way that we came up was to kind of selecting the desirable quality attributes for a given system, and by seeing the system and checking a box, for example, for decoupling or for security, we could provide the user with which patterns to be detected and that are closely related to that quality attribute. So, for example, if you wanted to be focusing on the low degree of coupling between different microservices, we could dispatch the detection for database per service, for example, or for asynchronous messaging between the services. And I think this is a kind of a practical way to address this issue. And it's a little bit out of the scope of my master, but it's so closely to what we have today and so important that I'm actually already trying to address this point at this moment. So this is one practical way we think it's possible to bring the quality attributes back to the patterns. But there's still work to be done in this sense.
No, I totally agree with you. In fact, that observation from the practitioner that there's a drift, for example, so he was able to detect a drift. And maybe if you investigate further that drift and you try to think about the drift in relation to the quality attributes, because at the end, a sound architecture or sound pattern should balance between the quality that you're interested to implement, right? And the drift is very likely to tell you that there's something wrong maybe about implementing for security or implementing for fault tolerance. So you have to be careful here. Or maybe this pattern, you think that it's fit for purpose, but it's not. And I think, that observation about using your technique in order as well to help architects evaluate the architecture and to think about where are the places where there's drift. And maybe you could take that drift and you could try to rethink the drift from a quality attribute point of view without doing too much work. But I think what you provided is an excellent start. And, I'm really impressed about the quality of the MSc in Sao Paulo. And, keep the great work.
Thank you. Thank you once again.
From me, yeah.
Thanks a lot, Rami, for your comments. All of them great, and actually they made us look to the future in a very we have a very promising research ahead of us. So thanks a lot. So now I pass the word to Professor Nabor to your considerations.
Okay, thanks, Eduardo and João, and also Alfredo for the invitation to be part of this evaluation committee. It's also an honor to meet Professor 𝜇sVision in person. I know him from his papers, of course. So it's also like a special occasion for me to meet him as well.
My great pleasure as well.
So I basically agree with what Professor 𝜇sVision said before regarding the work. He made some very interesting and quite insightful observations. But I had some more doubts and things that were not so clear when I was reading your dissertation. And I made some notes. Usually when I do reading a paper, I start writing notes as I go along reading. So I will send you my notes through email, so if you can benefit from them somehow, when preparing the final version.
Sure, thank you.
But of course, I will focus here on a few points that I think could take the opportunity to have some clarification from you. First of all, and I was surprised to see that my concern, let's say, my concern. Was addressed right in the beginning of your document. Was it's basically 2 line of works in the same document, and you mentioned that they started for the common, let's say, goal, but they departed during the work, and then have kind of different works, although they are related. They are sort of a different work. The interview part, and then the tool and the pattern detection part. and so I was like, it's a little bit like disjoint, I would say. But you sort of admitted that in the document. They said they do two stuff, so they are here. So we put it. And I write in my notes that I'm biased, and I'm more like keen to tools and detection and analysis than to interviews, which like software engineer now is full of those interview works and surveys and so on. So if I was your advisor, which of course I'm not, I would say just focus on the tool. It's good enough, it's interesting enough. But anyway, but curiously, your title is basically focused on the tool and the detection. So perhaps you and your advisor agree with me when you decide to define the title for your work. So I felt like this is like my negative criticism. I felt like the interview part feels like off in the document, you know, a little bit like we did that, we cannot like throw it away. It's some interesting results, so let's put it there. So, but I think that is reasonably well addressed in your introduction when you describe your methodology. So it was interesting. So I will focus on the tool, which basically what Professor Amy also did. My main concern, I come from the architecture recovery background many years ago when I did my PhD with in Imperial College. And at the time, architecture recovery was like a hot topic, and I focused on distributed software architecture recovery, which like brought a lot of challenge because the interaction, the connections between components are not like so explicit in the source code, which was like the main source of any architecture recovery or design recovery tool at the time. So I did like static analysis, I focused on the source code, but try to infer runtime features from the code. Like if there is like, my time was like C, sockets connections, things like that. But nowadays it's like more common because like service-oriented system, microservices, they're like, oh, they are runtime architecture with like distributed interactions. So my main question, and I think I didn't find it in your document, you could clarify. You didn't actually describe how you actually collect your metrics. For example, how do you know, how does your tool identifies that a service A is actually interacting with service B and C, or whether there are multiple services like accessing the database service? How do you know how many operational service provides? There is the requirement. You sort of got these metrics to do the reasoning to detect the partner or not. But I didn't see in the document, or at least I missed it, how you actually detect it. So could you like briefly describe or explain how does this part of it work?
Sure. It's great to know that you have this recovery background and experience, because the automatic recovery of an architecture is it's kind of an effort into a pain of the developers, because collecting the data is hard when done manually. And in our work of this master, we did not collect anything automatically. All the collection was done manually. Actually, it was done in a joint effort with Tatiani, because she was trying to validate her model with real-world data, and I helped her by discussing the source code that we were analyzing, and discuss the process took basically two different paths. For one of the systems, for Intercity, it is an open source tool platform, and we had access to the source code. So we were the two of us were pairing on top of the of the source code, and seeing, okay, this microservice is connecting to this database. So we wrote down and collected this manually, and we did not collect the metrics by themselves. We collected data to support the extraction of the metrics. The second system was more, the work was a little tougher because we need the Handicraft Marketplace is the fantasy name we created, but it is actually a real-world company. It's an e-commerce for handicraft products, and we didn't have access to the source code. We needed to interview the developers to acquire the data. So this data collection, this raw data collection, was a very extensive work done manually, entirely manually. So this ended up with the with data for the input of our model. With the data modeled into our application, then I can explain a little more how to extract the metrics. So I knew which microservice expose, which were the operations, for example, each microservice exposed. And based on that, I could, let me go to the slide of the metrics. Where is it? Okay. So, for example, the number of clients of a given given database, I would navigate through the graph that represents the system with the data that we collected manually. And by this navigation, when I was visiting a database, I would count how many different microservices it was connected. So there is the weak link in this step of collection is actually when we affirm that this microservice is actually connected to this database. We don't have runtime data to support this, and we manually collect it. So it's slightly it's a hybrid approach. The extraction of the metrics is automatic, but it's based on the data that was the raw data that was manually collected. So we have this kind of I don't know if bias is the correct word here, but it is definitely the weak spot of this metrics.
So I see. So you basically define a sort of an architecture model, sort of this graph, and then this graph should be the input for your tool right now.
Yes.
You compute the metrics from this input graph, and then after that you can infer if there is like a pattern or not based on the structural metrics.
This is actually what I'm presenting now. This is the input of my tool, a set of information according to this model. I don't have the raw data or the source code, nothing. This is
okay. So this brings me to my second question related to this, exactly the same point, which when you describe related work in your chapter, the interview part, you sort of that's like a critical view of what the existing work compares or differs from your work. But when you mention those, there are a couple of them now, architecture recovery tools for microservices applications. You basically describe those tools like a simple sentence, but does any comparison with your own tool. So I was wondering if those tools do actually extract like this architectural runtime information, and the information that those tools extract, if they're could be used as input for your own tool, or you could reuse the extraction part of those tools, or implement a similar mechanism that could be used or from your own perspective, like because you did all the extraction manually, how easy or how difficult it would be to automate this process, or to write a tool that could gather this information. For example, runtime information in my time was more difficult to get. I had to instrument everything and go into the code and all those instrumentation. Now with microservices, all those monitoring tools, for example, if you have like a service mesh, you can basically extract. And actually, there are tools like if you use like Istio service mesh, they come with some visual tools that show you the interaction happening at runtime, because those metrics are being collected by the proxies, the data plane, then being it's sort of Prometheus, and then there is a tool that can gather this information at real time and show you which interaction is actually with problem or given error or too slow. So this kind of graph is actually easier now to be extracted from the current ecosystem of microservice tools. So you could like basically have your tool and integrate with this kind of recovery. But perhaps you can talk about your experience. I see, like, for example, a Docker Compose file for a microservice application. It's very common to deploy the application with the Docker Compose file, or even like a Kubernetes configuration files. And they basically architectural descriptions of the application, because you have to say which service depends on which other service. The Docker Compose, you have to, if there is a dependency, the service that is dependent upon other service, the other service goes up first. For example, a database and then an application service. And I see like a Docker Compose file as an architectural description, like an EDL from the old days. So perhaps, of course, you can see if there is like any inconsistency between these files, these configuration files, and the actual architecture at runtime. But I don't know, maybe it would be easier to get the information you need with all those kind of tools that we have today for the microservice ecosystem. I don't know if you have anything to say about it.
No, I absolutely 100% agree with you. It would be easier to have automated collection of this data, and there are many tools that are reliable reliable tools for collecting this data. I think the short version of my comment is that we decided to focus on the detection instead of the extraction of the metrics. Even the extraction of the metrics, I would, in a more in an ideal world, I would have also a tool to extract the metrics for me, and I would only focus on the detection. Actually, about the related works that you initially commented, there are many different works there that recover the architecture, and there are works that even detect bad smells in microservices, and they do everything from the ground, right? They collect the data, they analyze the process, and they indicate where the bad smells actually are. What we had in our reality was that one work was very important for us, given the context of my master's. It works and collaborates with many other researchers that work on top of the Intercity platform. And we had a little trouble to find tools that could collect the data from Ruby on Rails. That is the basic, the main framework for this application. So from the start, we decided, okay, I think it's hard, but it would be easier for us. We would have more control on the process if we collect these metrics, this data by ourselves, by hand, manually. But on your second part of your comment about the architectural description, it's when you see a Docker Compose file or a Kubernetes deployment file, all we see, it's like a blueprint of the system, right? The infrastructure. And we also have tools like Prometheus and Grafana who can support with runtime metrics live, right? The system in execution. And I think that there is a lot of room to improve how our tool can be connected to other tools. For example, one related work was very interesting. I found it recently. It was a static analysis tool for bad smells in microservice that was integrated to GitHub. So when a person submitted a pull request, the tool automatically analyzed the changes and the overall architecture and commented on the pull requests, saying something like, okay, this there is you're introducing a bad smell here, so be careful, and something like that. and this, I think it's something that for sure inspires me to future works, more specifically in my PhD, to try to work with something. We don't have to reinvent the world, right? We can connect to tools that are already there, and I think this would be probably one of my next steps in terms of my academic career. So to work with research that communicates and integrates with the related works and to other tools that can like scaffold some parts of my work.
Okay, just going to my final observations. So some of those like things that are not so clear or doubts that I had are more like how you express them in your document. For example, to make it clear that the abstraction is not part of the tool, because sometimes for you, because you know everything, it's clear. For me, I had an expectation of somewhere you're going to describe the abstraction, so you can make this like even more like evident or clear right from the beginning to help for the reader. The same thing, for example, I think there is an interesting part when one of the developers mentioned, how do you know that you have a join in a microservice that I implemented the pattern? That's because of course, you're only dealing with structural data. So your pattern is expressed in terms of structural metrics. So I think you should be more explicit about that. You're not like fully recover the semantics behind the pattern implementation, because otherwise we only are aware of that when you mention that you cannot recover it. So it should be more explicit right from the beginning. It doesn't diminish from your work, but it makes clear that it doesn't create any expectation for the reader. So it's good to have like the scope and the limitations well established, so you don't create any expectations, because sometimes you are a little bit disappointed with the work, not because the work is not good enough, because you expect much more from what you start reading in the beginning. So my final observation is a minor thing, but it's a curious thing. You mentioned, I think in the first chapter, in the second chapter, that the term microservice was coined 7 years ago. So assuming that you wrote this like recently, so you're assuming that the term microservice was created like 2016, 2015. So my question is, where did you get that information?
Yeah, I tried to see when was the first publication that came to the academia with the term microservices. To be honest with you, I thought I had this referenced correctly, but there might be a missing link there. What I found was a paper. Actually, it was a presentation done in a company in the end of 2012, and it ended up with a blog post of, if I'm not wrong, it was posted in Martin Fowler's blog in the beginning of 2013. So it's actually
more than 7 years.
More than 7 years, right? Yeah. So it's my bad math of my.
It's part. Interesting because you know that.
Yeah, it's
not correct, but you did
2012, 2013.
The only reason I'm asking this because we had a paper that was the introduction for the special issue Microservice for IEEE software. It's quite well cited, that paper. And I was one of the guest editors, and I work on the timeline that I actually wrote a timeline of the technologies that were proposed throughout the last decade up to 2018, when the special issue was published. And I was particularly curious about when the Microservice term was first coined. And then the information is there in the Martin Fowler and James Lewis blog post. And then I put in my picture, if you look at that, there's a timeline, and then there's just out of curiosity. need to make some advertising. If you look, the paper is open. It's
Oh,
open.
thank you.
It's open.
I
If
would
you go
ask
there,
you the link.
and there is a picture, you don't need even to download the PDF, because the HTML is open. It's free access.
Okay.
And then there is a picture where I draw the timeline, and I put the dashed line saying the first time the term microservice was used, because I got this from the Martin Fowler's blog post. It was around 2011, and then it was mentioned in that presentation 2012 and 22.
So it's definitely something.
You are correct, but basically it's over 10 years now.
Yeah.
11, 12 years, not 7 years.
Yeah.
So just as a curiosity, I'm glad to know that you know that it's not 7 years. So.
Yeah,
Anyway,
it's my bad. It's my bad.
So as I said, I had like more detailed comments on other parts of it. I will send you through email my comments, and then again, congratulations on your work, and congratulations to your supervisor and co-supervisors for the work. And I'm glad to know that we are moving to the Italian Alps.
Yeah.
For your PhD. I thought you were going to Birmingham. When I saw
I was actually invited, but the plan A was to go to Bolzano.
Yes, you cannot go. I don't know. Maybe you can go skiing in Birmingham as you can go in the Italian Alps. Anyway, thank you.
Yeah, but here we have pizza all day at lunch.
Yeah.
Ma che bellissimo.
Okay, so that's the end of my part. Thank you very much.
Thank you again, Professor.
Okay, so thanks a lot for your comments. Also very curious, this issue about the term microservice. Very interesting. Thanks a lot for all your comments. Now it's I give myself the word. I just wanted to thank you all for your comments and thank João for this period. Actually, I have the privilege to collaborate with João before his master in his bachelor work, right? He wanted to work with frameworks and microservices. Then came this invitation from Alfredo to participate on his work, and maybe he likes working on this kind of thing and continue on his master, right? And now I'm really glad that he will come to Bolzano to continue this, let's say, academic adventure. And what I can say about João, one thing that me and Alfredo, we always highlight is that, for example, usually we have a meeting and we have an expectation for the next meeting. And João is the student that always comes to the next meeting with much more than what we expected. Not only he developed these ideas, but he also go further, have new ideas, have, let's say, already went and experimented a little bit. And it was really a pleasure to work with him. About the work itself, I think it's very interesting, this issue about getting more information about the systems that allows people to reason better, to make better decisions about this. And I was really glad about the interview result, which show how this kind of thing in practice, it's even more important that we anticipated, how they see and how they can get a better, it's like give a step back and actually have a better vision about the system. So I'm all thanks today. Okay, so now we go to our private session, right? To decide about João's future. João, I think, tried to create some kind of another room, but he did not make it. So I created myself a room in Meet. So we leave this meeting, enter there, or maybe we can just mute here and enter the other one. I think maybe worked. And when we finish, we come back. So João, you just keep there waiting.
I'll wait here. Anxiously.
Yeah, I'm sorry. Can you just give me 1 minute and I'll be online?
Okay, perfect. Are we going to wait for Alfredo?
Did he show up in your?
Yes.
Yes.
Oh,
Oh,
here
Ah,
he
he's
is.
there. Okay, so I officially announce that João, you are approved. Your thesis was unanimous approved, and you are now a master in computer science.
Congratulations, João.
Thank you a lot. Thank you.
Congratulations.
Congratulations.
Alfredo.
Congrats. Great, great.
Yeah.
I was here at the end, at least.
Thank you a lot. I would like to say a few words. First, I would like to make, for those who are more acquaintance of me, know that I'm very performatic, and I would like to make a little joke in Portuguese. O importante é conquistar aí os 3 pontos, né? Como o professor falou, a gente tem que focar aí no próximo jogo, né? E, então eu queria agradecer minha família e a minha esposa e obrigado. So, but now I would
like to translate.
I would like to seriously say a few words in English. I would like to thank for all the support.
3 approvals, you can ask music.
This Sunday, oh, fantástico! I will ask for music. I would like to thanks my now she's my wife, but she's been my companion and my partner for the last 5 years. Next week I will turn 31, and which means that my parents have been supporting me for the last 31 years, and I would like to thank them. And finally, I would like to thank Alfredo and Eduardo for letting me climb onto your shoulders, because you are for sure giants. Thank you.
Thank you.
Well done. Yeah.
Well done. Well deserved.
And thanks a lot for Professor Narbor and Professor Hami for being present here. Professor Hami for your contributions on my qualification exam too, and for well, everybody who have been around my projects so far. So thanks a lot.
Our pleasure to help.
And I'm higher than Alfredo, so I'm a bigger giant.
And good luck for the PhD.
Grazie mille.
Yeah. Yes, and I think the lesson is, and I will say the same thing when you finish your PhD, it's not the end, it's a new start.
Yeah.
Yeah. So
Great. So I will, Alfredo. Then later you let me know what I need to do.
Don't worry, I can take care of the work.
Okay. So thanks a lot, everyone, and thanks, João. And now celebrate.
Congratulations again. Thank you very much for being
thank you.
on the meeting.
Our
See
pleasure.
you.
Okay.
Bye-bye.
Thank you.
Bye-bye.
Congratulations. Thank
Bye
you.
bye. Bye
Bye.
Thank you.
Parabéns aí, João.